We researched anthropogenic noise on the UO campus. My name is Margo.
I'm Nithi.
And I'm Josh. So a bit of introduction to our presentation. So to start off, defining anthropogenic noise, it is any noise created by human activity. This noise can affect the work done by students in certain environments. For example, areas with more anthrophony or noise created by humans will provide a less productive environment for studying. Different locations on the University of Oregon campus will have varying levels of anthrophony. For example, the library will be quieter due to the social construction and expectations of its location on campus. Places like the EMU and Lillis College of Business Atrium don't have the same social standards and are known as loud communal places. We examined the effects of weather on anthropogenic noise. We believed at the start that the weather will influence anthropogenic noise by impacting the amount of time students spend in buildings. For example, in hotter and sunnier weather, students will be more likely to do their work outside than in a building because they can sit on the lawns in the nice weather. However, on a rainy day, we expect to see the opposite. Students will likely work inside as they cannot work outside during the rain. This information leads us to construct the research question: does the amount of indoor anthropogenic noise produced on the UFO campus vary depending on the weather?
The locations we chose to record are the EMU O-desk, the first floor of the Knight Library, and the Lillis Business Complex. In these buildings, each person in our group recorded anthropogenic noise on our cell phone using the Dayton Audio IMM6 calibrated microphone for 10 minutes 2 times a week. We use Raven Lite software on our laptops to import our recording and view individual spectrograms for each recording. We filtered each recording down to 5 kilohertz in Raven Lite and calculated the average power density for each. We also used a random number generator to find a random minute in each 10-minute recording, and we calculated the percent of the minute which has the anthropogenic noise. Each data point that was collected was stored in a shared Excel spreadsheet along with a screenshot of each spectrogram. Finally, we used an Excel to generate 2 scatter plots, one comparing the percent of random minute with human noise to temperature and one comparing the average power density to temperature. It should be noticed that the power density values closer to 0 indicate that sounds are louder.
Here we have the 2 graphs we made using our methods. Through our research, we found that anthropogenic noise that we measured could be influenced by various factors, including weather and location. The EMU has the highest power densities and percentage of time with human-made noise. Lillis was second in both categories, and the library was third with the smallest amount of human-made noise. We found that hotter temperatures decreased the power density of noise in the EMU drastically. However, there was little correlation between weather and power density in the other 2 locations. Temperature had no effect on the percentage of time that had human noise in the EMU. However, higher temperatures increased the percentage of time with human noise in Lillis and decreased the percentage in the library. The power density and the percentage of time with human noise also varied weekly. For example, the library had more noise during the weeks most students had midterms as they were studying in there. Recording times varied by time of day of the week, and week of the term. We didn't examine the correlation between the time and anthropogenic noise created, and therefore cannot formulate concrete conclusions or form any connections between the 2 factors.
We conclude that different weather patterns can affect indoor anthropogenic noise levels because depending on the location, students may be more inclined to stay inside if it's raining or go outside when it's sunny. Certain locations within the buildings we measured, like those near high traffic areas and mechanical equipment rooms, may be more prone to noise production than other locations. We found that indoor anthropogenic noise production consists of many things, including conversations, music playing, sounds from technology, and background noise from building mechanics. Ultimately, we conclude that as outdoor temperature increases, indoor noise levels decrease slightly in the EMU, but not notably in the Knight Library or Lillis. Our group only consisted of 3 members, and we only had 4 weeks to complete this project. Because of these limitations, we were not able to conduct extensive data on the average power density and percentage of time with human noise in each location. We also could not record in additional locations due to our small group size. We relied on the technology provided to us in our HC 301 research class and did not have access to higher quality microphones and data analysis programs. These factors contributed to limit the scope of our research.
In the future, having more time to collect data would allow us to make a more concrete conclusion on the correlation between weather and indoor anthropogenic noise on the Yale campus. We could also examine the effects of anthropogenic noise on the types of work being done by students. We could design a study that gauges the impact of productivity on certain levels of anthropogenic noise.
Lastly, we would like to thank Lisa Munger for advising and supporting us throughout this process.